Yes? You hear me? So I wasn't expecting that much for the last talk. Not much people.
We can go.
Yeah, I can do it at the community dinner. Okay, that doesn't work either. So, let's start very quickly. So my name is Frédéric Descamps. You can hear I'm speaking French usually. So I'm tired, so if you don't understand some of my bad English, just let me know. So I'm working for Pocona, I'm a senior architect. I do MySQL since a lot of time. And which is fun is that I started to use Galera since February 2010 when I met Seppo here in FOSDEM. So you can see nice stuff in FOSDEM. And I started with it. So today the talk won't be too technical, and but who here is using Galera? Okay, with MariaDB, with MySQL community, with Pocona. Okay, that's good. So what I will show you now is valid for all of them. Okay, so it's about Galera and how Galera works. Who think it's a bit magic and doesn't know how it works? One guy? So I will try to explain that magic today. I won't explain everything about what's easy, I would say. We'll go in really where it's tricky. So the certification, for example. This is where it's more a bit complicated. I want to explain it. But for the people who doesn't know Galera at all, usually when we talk about MySQL replication, we have a master and a slave, right? So this is and a stream between the master and the slave, and this is what we call server-centric replication. We have a master and a slave, they have a role, right? With Galera, here it's different, we are data-centric, so we don't care about the role of the server, but we care about the data. So don't try to cut filters like, oh, I don't want to replicate this table or this database. Don't play with that, it won't work. So you have data everywhere and you see it like one data, right? You don't care about if they are out of sync or not, it will worry for you, and you can write everywhere, normally, depending on your workload, but it works. Something which is nice also is that on a database you write in multiple threads, so you don't have only one client that writes, and you can also apply them in multiple threads on the other nodes. The threads are not the same. You have to define that end here, right? But you can do it. By default, you can make more. So what's the replication, in fact? Replication is to deliver the right set that are going to the nodes, to all the nodes in the cluster. So you have a write set transaction, and you need to deliver it to the other nodes. And all the other nodes acknowledge they got the right set. Then they generate, so the cluster generate GTID, that will be global, and that will be used to order this transaction. And the cost, it's a round-trip latency to the furthest node. So if you have nodes, let's say in Europe, and one in Japan, the speed of the cluster will be the speed to reach that node in Japan and come back. Okay, so what shall we say? Oh, it was fast, we were happy with this, we just moved one node in Japan, and oh, it's very slow, our application is slow. It's normal, because the latency there is much higher, right? So the GTID is serialized, but you can anyway write and replicate in parallel. So because they communicate. So let's talk about these GTIDs. So they are not the same as 5.6 asynchronous GTIDs, but they look the same. So this is one GTID. So nothing special about it. And these GTIDs, they will ensure that all the members are consistent with each other, right? So when they join, they say, oh, this is the GTID I had, or I was to the GTID, or this is my current GTID. What's the status of the cluster? And then we know where we are in terms of data, right? So when a node joins the cluster, we check the GTID. And we say, oh, we are missing some transaction or not. And if they are missing some transaction, we're going to give him the data to that node. So when we stop all the nodes, we can use the GTID also to compare them. So where is my most accurate node, right? And we use the GTID to see that also. So highest GTID means the most recent data up-to-date server or nodes. And so it's better to always restart. So if you stop all your nodes, check first which GTID is the highest, and then restart from and bootstrap your cursor from that node. Depending on what version of Alera you are using, this is automated in some version and the new version. So some more about GTID. So this is what it looks like, and the GTID in fact represent the dataset ID, right? So we have here dataset ID or the cluster ID, same everywhere on all the nodes, like they said this morning in MySQL 5.7 group replication. And then we have this transaction number, right? So we know, okay, this is the transaction we have done. And every time we do a transaction, we increment this, this counter here. So if we compare them, they look the same, right? But this is the dataset cluster ID. In 5.6, this is the server ID. So every server will have their own GTID, this part of the server ID of the GTID. This is the data change inside of the cluster, and this is the transaction that are processed for that server, right? So in 5.6, we write data, so we increase, and when we promote a new master, so it's another node. So it's another ID here, and that starts processing transactions. So we have changed, and we can see it from there. In Alera, let's say we write always on the same node, then it's another node that gets the writes. Nothing changed. We just increase. Okay. So this is the big difference between these two. So how do we assign this GTID? So the UID part, it's 128 bits, and let's say it's completely random. And there it's, yeah, you should use the MAC address and stuff, which is not really the case. You can find I put here on this GIST some information related to the code, so where it's generated if you want to see. But let's take it's random, so there is nothing that you don't take control of it, I would say. The sequence number, this is a 64-bit, and it's generated during the replication itself. And it's the group replication. So when you do something and you write, they communicate together and they decide what will be the next sequence number. And for doing that, they use an algorithm which is called Totem Single Ring Ordering Protocol. I cannot explain you everything in that time on what's inside of it, but this is how they decide what will be the next GTID. So just Google for it, and you will, or in Wikipedia, and you will find really some white papers on how that works. So replication roles. Remember, I said, okay, we don't care about who is the master, who is the slave, because we can write everywhere, and everybody gets the reads. But within the cluster, so all the nodes are equal. But we also sometimes discuss about, or if you check the forums or the bugs, about the master node. The master node means the node where the application was connecting and write the data. So you can switch of them, but for one transaction we're going to write somewhere, and this is the master node. So this is where we're going to commit the transaction, and the slave node, it's the other node that will receive the transaction. Okay. So this is, even in Alera, we also say master and slave. But this is just for a given transaction, not for the server itself, right? So this has to be very clear, and because sometimes people insert bugs and then discuss that, yeah, which node was the master? None, because I'm doing a secret application, I don't have master. Yeah, but for your transaction, there was one master, so which node did you roll stuff? Right? So, yeah, and what's a write set? Because I always say transaction write set. is just the term in Galera for a transaction. It's one or more row-based replication event. The binlog format has to be row in Galera, and so this is this kind of event. So the write set is this RBR payload. It's a bit black box in Galera. And we also need replication keys, that the master node will generate that. And these replication keys, we have the primary keys. So if you remember, or if you are using Galera for a long time already, at the beginning, if you not had key, it was very bad. You should have the primary keys. So table without primary keys at the very early, let's say, age of Galera, you could not even work. So primary keys, unique keys, foreign keys, table name, and schema name, all these together will be part of the write set to be able to make this certification, to see if there is conflict in the data we are writing, right? So, and in the new version, if you don't have these keys, it can generate for you. But it's always preferable to have primary keys. All InnoDB best practices are still valid and much more valid in Galera than in InnoDB itself. So the keys are shared exclusive, and this is what we use to make the certification possible. So we say replications. For us, what's replication? It's I write data somewhere and it gets somewhere else committed. Oh, I'm happy, this is replication. But replication, when we talk about synchronous replication, it's a bit more. Because we can split this replication in several steps or phases. And the first one, it's apply. So we need to apply the change, so the data itself. Then we need to replicate it. We need to certify, and we need to commit. And this order can be different depending on what's the role for that transaction. And I will show you, for example, on the master, so the machine where the server that gets the transaction to be done, it applies. So you modify rows, it modifies the rows, then it will sense the replicate to all the other nodes, then certification happen, and then if certification pass, it commits. On the slave, it gets the data first, then it certifies, and if certification pass, it will make the change and commit. Okay? So this is different. And what is then the certification? I go a bit fast, we can discuss later as there is nobody after me, but I would like at least to go through the slides. So what's the certification? The certification is just answering this main question. Can this right be applied on the machine I am trying to do the certification? So if I can apply, so if there is no conflict, then yes, certification pass. If there is something that blocks me to write that data on the node, then certification fail. You're going to see that after. But also so, and how, what do I need to check? I need to check the data, and also based on the unapplied earlier transaction on the master. So it could happen, so when I do the certification, that there is some still transactions that are in the queue that are not yet applied, and I need to verify there too. Because depending on the speed of the nodes, I need to verify all that to be able to make this certification happening. So when there is a conflict, the conflict should always come from another node. So that's why, depending on your workload, if you have a data, one table or one record, you always change. Your application always change the same record. Then we will tell you, okay, Galera is maybe not good for you, or at least not to write on all the machine at the same time. You need to write only on one node, and if that node crashes, write on another node. Because they will have too many conflicts. Because you will write on all the nodes the same data everywhere, they will conflict. Certification will happen on every node, and is deterministic on every node. Here, the results are not reported to the cluster. So this is, I don't know if Thiago is here. Yeah. Before you said, oh, we write and we wait that they get before we could commit it.
There is no communication system.
Okay. Because that was...
The total order.
Okay, so here is also the thing. So we don't, so we send the data. When we know the data it's arrived to the slave, or to, let's say to the other nodes, then we don't care about them anymore. It's enough. So if they certify or not, we don't care. It's up to them. I will show you that, I will explain you that. If it works, so if certification pass, we go in a queue, right? And the commits will be done on the master. If it fails, we have to drop the transaction. And on the master, we give a deadlock. If it's not a real deadlock, it's deadlock that mostly happen after we commit, and that's where the application needs to be able to do that. So to when it commits, it gets a deadlock and deal with that, because it's the only way we can discuss with the or return that certification failed without changing all the MySQL protocol. And the certification is serialized by GTID. The certification has a cost, and the cost for it is the amount of keys or the amount of rows. So if you have, let's say, by default you're limited in 1 gig, and you can go to 2 gigabytes of changes, but you can understand that if you have always to pass and certify all these 2 gigabytes of data, it could be a lot of work. Apply is done on slave nodes after certification. They are parallelized if the reserved slave threads is bigger than 1, not the default, and if there are no other write set that could conflict with it that are being applied. The cost is also the size of the transaction. So that's why if you have large transaction, it's very bad for Alera when you write everywhere, because then you will have more conflicts happening. And this is where you try to not to do. So on the local node, we will, if the apply doesn't work, we will have a brute force abort, and I will explain you what it is just after. So when we commit, so this action is just writing the data, committing like the normal InnoDB commit, and like flush local transaction commit, and it's done. Okay. We serialize also that by the GTID, and this is done by the applier threads on the slave and on the client thread on the master. Okay. So now I will show you some graph on how it works. With auto commit, what happens is we do a change on one node, it replicates, right? Then it's certified, and here what you can already see is this. This is the only synchronous. When we say it's synchronous replication, yes, replication is synchronous, but the commit and certification is not synchronous. It will happen at a different time. We try to make it as fast as possible, but it's not true. It could take time here in between, because we don't know the load of the other nodes, and we don't care, in fact. Of course, if you have a node that is lagging, you will see later, it will cause that all your cluster will be lagging at a certain point. But you can see applying and finaling the commit never happen at the same time. It could be very long time after. Of course, more long it is, worse it could be, and more, let's say, conflict you could have. So you should be very, very careful on that. So it's the same for when we do a transaction, full transaction, right? We do all the statement, it gets replicated, and we commit at different time. So when we say synchronous replication, yes, replication is synchronous, but that's the only thing that is synchronous, not everything. So not like when we say MySQL replication, it's because, let's say in the past, the replication was I write data and it's replicated. It's when the data is written on the other side, when we have asynchronous replication. Here it's not the case, right? Just to show you how the traditional locking works. So when we have on the same machine multiple transactions, and we need to wait here because we have a lock, right? And on a cluster, distributed system, we don't distribute, or at least not yet, with the Alera version we have until now, we don't distribute the locks. So they don't know what they are here. There are two different transactions on two different systems, and it's only at commit that they start talking together, and at this time, the second one, so latest one, will have an error because it has a conflict. But just when after we commit, not before. So here is just some explanation of certification failure, right? So we change same data, we commit here, we synchronous replicated the data. Certification, it's happening on all the nodes. Then certification will succeed on the nodes. When it succeeds, we go in the queue, right? Everywhere it succeeds, we commit. The commit succeeded here, the data is there. Then it's still on the queue to be processed. Where we commit here, certification will check with the queue if there is nothing that has to be applied that could conflict. And here, certification, when it commits, certification will fail. Here, the certification for this will fail also because there is a conflict. Here, it has a conflict because we keep the information we have changed. And so, here, certification fail, we're going to return an error. And everywhere, certification will fail, we will not commit the information. And here we got to have a rollback, and we send to the application, okay, we have an error. So this is just some slides to explain how all that works. Because we have two types of certification issue in Galera, brute force abort and local certification failure. And so this is some illustration on how that works. So here you see we modify, we have a transaction that's open, we modify the data. Here we have the same data that we modify on another node. When we commit it, it gets replicated, it gets certified everywhere. Then when it works, it's applied everywhere. When this one, we will do, the next thing we will do here, whatever it is, we will have a deadlock coming. The deadlock already happened by this one, because he said, oh, I have to brute force abort that transaction, but you will get the answer only at the next statement here, not before. And mostly it's always the commit, and then you get the error at that time. Okay, but this has been already implemented. LCF, local certification failure, same stuff. We do, you see, we do a transaction. They are in the queue. They are committed. Then on this one we replicate, and here there is a conflict between something that is in the queue, and then we have again an error, deadlock, and this is certification failure. Time's up, I know. Sure, but you know, I give 5 minutes to everybody. No, not 5, 2 or 3 minutes to everybody. I need to recover them now. But there is dinner, that's true. Just one thing on flow control. Because you have seen the nodes are not committing at the same time, and they can have delay, we need to be able to control that delay. And this is where flow controls happens. And this one, it says, okay, we allow some delay, but not too much either. Because if we have a too long delay, we could have more and more conflicts, right? And this is what you need to monitor, in fact, on the Galera node, is that you don't have this flow control going back, right? So it happens only when the receive queue is higher than the limits that we give for the flow control. And when flow control happens, what it really means is that the node will say to the other one, stop processing anything. I need to flush my queue. So I'm too slow, I need to do some work, and there is too much in my queue. I reach the limit, so everybody else will not do anything. So your server is completely stalled. You cannot write on the server anymore, right? So if it's too low, you will have flow control coming too many times, and it's, oh, let's make it very high. But if you put very high, you will increase the conflicts if you write on multiple nodes. So watch out. And this will also increase the apply lag, because just to verify many stuff when doing the certification. So if there is always the same node with flow control, then check what it is. Does it has a bad hardware, or the configuration is not the same compared to the other one? So yeah, I will let you show this graph, but you just know that we see this one is not applying anything, and he has the limit here, and he has the queue. At a certain point, when we reach the queue, it says stop to all the other ones, and everybody waits nothing happens because they need this one to process the stuff. Okay? That's it. Do you have question? Yes? No. No, it's deterministic, so it will do on on himself. So it does the certification. You see with this queue, for example, you see if there is nothing in the queue that he has not yet processed that could get conflict. And if it passes there, it will pass everywhere. Because the GTID and because we do optimistic replication, let's say it like that. So if we pass once, we say it will pass everywhere. And if it fails somewhere, then that node, so for example, it passed everywhere but one node, that node says, oh, if it for me, I could not do it, so I have an issue, my data is going to be corrupted and it stopped working. It goes out of the group by himself. Okay? No, it goes out and then you have to restart it or something like that, and then it will rejoin and get the data. Yes?
What about the reads? The commits happen at different time in nodes. Is it possible that I get different results when reading data?
Yes. Yes, by default, yes. And then you have some settings that you can say, depending for inserts, delete, you can say some data that you say, when I will read data, I want that the queue is processed. It's me, the development manager, but I'm the last speaker. My t-shirt is over there.
He's like the man in charge that everyone is different time.
Yeah. So we have the room until 7. So yeah, you can, but you can play with that and say if you want to read and be sure to have the same data. You can say you read only when the queue is processed. Another question? Okay, see you at the beer. You can change. You can on the first version, no, it was just or for everything, and now you can say for reads, for updates, for deletes, for inserts, for everything you want. And it has some increments, so it's from 1 to 6, and 1 means this, 2 means that, the 3 it's inserts and delete, and so you can play with whatever you want on that. Okay, see you at the community dinner. I heard you will join.